Hi learners, good day. Welcome back to General Mathematics Learn by Video series. This is still brought to you by QuexBook Smart Mobile Learning and PerkDC Learn Hub. I am Rex Jason H. Agustin, and we are now on simple and compound interest. At this point, we are done with Part 1, Functions and their graphs. We are done with Introduction to Functions, Rational Functions, Inverse Function, Exponential Functions, and Logarithmic Functions. Okay, we are now going to proceed to Part 2, Basic Business Mathematics, discussing simple and compound interest. Our targeted most essential learning competency for this session is illustrate simple and compound interest. Our topic outline would be basic terms, simple interest, and compound interest. In line with our MELC, our learning objectives for this session are to define basic terminologies in business mathematics, to explain simple interest, and to explain compound interest. Let us start with our definition of terms. First, we have here demand. Demand is the quantity of a certain commodity that is bought at a certain price and at a given place and time. It is the need, want, or desire for a product or service backed by the money to purchase it. We have here our demand curve. Notice that in this graph, we have price to be our independent variable and the quantity for demand to be the dependent variable. In this graph, we can see that the demand for a product is inversely proportional to its selling price. That is, if price is high, demand decreases. Okay? That is because people want to get more from their money. If the price is too expensive, there will be less people who will be willing to purchase that product or avail of that service. And if price is low, demand increases. We can observe this in malls. We can observe that there are relatively more people in malls if they are on sale, right? Next, we have supply. Supply is the quantity of a certain commodity that is offered for sale at a certain price at a given place and time. We have here our supply curve. Just like in the demand curve, the price is our independent variable and the quantity for the supply is our dependent variable. In this graph, we can see that supply is directly proportional to price. That is, if price is high, supply increases. The quantity supplied increases in response to an increase in price because existing producers will find it profitable to produce more at a higher price than they would have at lower price. Okay? Before I continue with our definition of terms, let me just clarify some things about our supply curve because you might be asking these same questions and it will be better if we can address them as early as now. Alright? Question: isn't it that if there are more supplies or goods available, the selling price would get lower? The answer is yes, it is correct. The selling price would get lower if there are more supplies or goods available. Follow-up question: if so, shouldn't the graph look like this one below? We have price on the y-axis and quantity of supply on the x-axis. And the curve is sloping downward to the right. Answer: yes, it is correct. In this graph, we can see that if supply decreases, price increases. And if supply increases, price decreases. Okay? So another follow-up question. Does that mean that the supply curve shown in the previous slide is wrong? The answer is no. It doesn't make the standard supply curve wrong. Okay? In the standard supply curve, this is the same graph shown in the previous slide. Okay? Note that the quantity of supply is our dependent variable and that the price is our independent variable. In the standard supply curve, price is our independent variable and quantity of supply is the dependent variable. Okay? In many other fields, the x-axis normally shows the independent variable and the y-axis typically shows the dependent variable. But this is not generally the case in economics. Okay? In this graph, price here is our dependent variable and the supply is our independent variable, which is different from our standard supply curve. Okay? I hope that makes things clear. So let's proceed with our definition of terms. Necessities. Necessities are the goods and services that are required to support human life, needs, and activities. These are the things that we need in order to survive. For example, as humans, we need food, shelter, and clothing. Next, luxuries. The goods and services that are desired by the human and will be acquired only after all the necessities have been satisfied. These are the things that we want but we don't actually really need in order to survive. For example, a sports car. We don't actually need a sports car, especially if we are not a professional race car driver. Next, utility. Utility is the power to satisfy human wants. If we spent 100 pesos in a day and at the end of that day we are satisfied, we can say that we were able to utilize our money well. But if we spent 10,000 pesos on one day and at the end of that day we are still not satisfied, we were not able to utilize our money well. Okay? Value. Value designates the worth that a person attaches to an object or service. Value can be subjective. A certain product or service can be too expensive for other people, but for some people, it may not be that expensive. Next, rate of return. It is a measure of the effectiveness of an investment of a capital. If you are to put up a business, you should consider rate of return. You should consider a business with a good rate of return. Then we have market. Market is the place where the buyers and sellers come together. It is a place where consumers can buy what they need or what they want, and a place where sellers can offer their products and services. Lender or creditor. A person or institution who invests the money or makes the funds available. In Filipino, ito po yung nagpapautang. Borrower or debtor, a person or institution who owes the money or avails of the funds from the lender. In Filipino, ito naman po yung nangungutang. Next, principal. It's the amount of money borrowed or invested. In business mathematics, when we use the term principal, we are not referring to the school head, okay? We are referring to the money borrowed or invested. Maturity date, the date on which the money borrowed or loaned is to be completely repaid. Maturity value or future value, it is the amount after 3 years that the lender receives from the borrower on the maturity date. Next, we have interest. Interest can be defined in two ways. First, from the borrower's viewpoint, it is defined as the amount of money paid for the use of borrowed capital. Second, from the lender's viewpoint, it is the income generated by the money which has been lent. So interest can be an asset or a liability, depending on our point of view, if we are the lender or the borrower. Okay? Next, we have nominal rate. It is the annual interest rate stated on loan, usually in percent, charged by the lender, or the rate of increase of an investment without adjustment for the full effect of compounding. Interest rate per period, the quotient of nominal rate R and the number of interest periods in a year M. Interest rate per period I is equal to nominal rate R divided by number of interest periods in a year M, where M is equal to 1 if the mode of interest is annually or yearly. M is equal to 2 if the mode of interest is semi-annually or every 6 months. M is equal to 4 if the mode of interest is quarterly or every 3 months. And M is equal to 12 if the mode of interest is monthly or 12 times a year. Number of interest periods is the total number of interest periods for a loan or investment. N is equal to M times T, where M is the number of interest periods in a year and T is the number of years. Let us now have simple interest and compound interest. Simple interest, interest that is computed on the principal and then added to it. And compound interest, interest is computed on the principal and also on the accumulated past interest. In solving for interest, we use this formula. Interest I is equal to principal P times interest rate I times number of periods N. We also use future worth or future value is equal to the principal plus the gained interest. Okay? Simple interest. In simple interest, the interest earned by the principal is computed at the end of the investment period. Let's show that through example. Example number 1. Jose invested 10,000 pesos in a cooperative group that offers 2% simple interest rate per year. How much would he have at the end of 4 years? Okay, so this is our problem number 1. In order to illustrate how simple interest works, let's make a table here. In the first column, we have period N. 1, 2, 3, 4. That's for first year, second year, third year, and fourth year. For the second column, we're going to write interest gained at end of period N. We know that interest I is equal to principal P times interest rate I times number of periods N. And on the third column, we're going to have amount at the end of period N. We know that future value is equal to principal plus gained interest. From the previous slide, we know that in simple interest, the interest earned by the principal is computed at the end of the investment period. At the end of first year, the interest P times I times N would be 10,000 times 0.02 times 1. That is equal to 200. So the amount at the end of first year would be 10,000 plus 200 or 10,200. At the end of second year, the interest gained is 10,000 times 0.02 times 2 or 400 pesos. The amount at the end of second year would be 10,000, this is our principal, plus the interest gained 400 or 10,400. At the end of third year, the interest gained is 10,000 times 0.02 times 3 or 600 pesos. The amount at the end of third year would be 10,000 plus 600 or 10,600 pesos. At the end of fourth year, the interest gained is 10,000 times 0.02 times 4 or 800 pesos. The future amount at the end of 4 years would be 10,000 plus 800 or 10,800 pesos. So for the question, how much would he have at the end of 4 years? Our answer is 10,800. Okay? In solving for simple interest problems, we know that the future value is equal to principal plus interest. We also know that the gained interest is equal to P times I times N. So factoring the principal P, we can get future value is equal to principal P times quantity 1 plus I times N, where F is equal to future value, P is equal to principal, lowercase I is interest rate per period, and N is number of periods. We can actually use this formula in our previous example. So going back to our example number 1, Jose invested 10,000 pesos in a cooperative group that offers 2% simple interest rate per year. How much would he have at the end of 4 years? We can use the formula F is equal to P times quantity 1 plus I times N. Substituting 10,000 for the principal, 0.02 or 2% for the interest rate, and 4 years or 4 for the number of periods, we get 10,800. This is the same answer that we have from our previous solution. Okay? Next, let us have compound interest. In compound interest, the interest is computed every end of each interest period, and the interest earned for that period is added to the principal. Again, let's show this through an example. Example number 2. Jose invested 10,000 pesos in a cooperative group that offers 2% interest compounded annually. How much would he have at the end of 4 years? As you can see, this is very similar with example number 1, except that we changed the interest from simple to compounded. Okay, so this is our problem number 2. In order to illustrate how compound interest works, let's make a table here. In the first column, we have period N, 1, 2, 3, 4 for first year, second year, third year, and fourth year. For the second column, we have interest gained at end of each period. Interest is equal to P times I times N. At the third column, we have amount at end of each period. Future value is equal to principal plus the gained interest. From the previous slide, we've mentioned that in compound interest, the interest is computed every end of each interest period, and the interest earned for that period is added to the principal. Just like this one. At the end of first year, the interest gained is 10,000 times 0.02 times 1, which is equal to 200. Okay? So at the end of first year, the value of the investment would be 10,000, the principal, plus the interest gained, 200 pesos. Okay? That makes it 10,200 pesos. For the second year, the interest gained at the end of second year, no, we're just going to consider the second year, which is 1 whole year. Okay, 10,200 times 0.02 times 1 whole year, or the second year, okay, that's 204 pesos. Okay, notice that instead of using 10,000 as the principal, we use 10,200, which is the value of the investment at the end of the first year. At the end of the second year, the value of the investment would be 10,200. Okay, this is the value at the end of first year plus the gained interest for second year. That makes it 10,404. Okay? For the third year, the interest gained at the end of that year, the interest gained at the end of 1 whole year, the third year, is 10,400. Now we use here the value of the investment at the end of second year. Okay, we add the interest to the principal. 10,404 times 0.02 times 1. Okay, that is equal to 208.08. So the value of the investment at the end of the third year would be 10,404, which is the value of the investment at the end of second year, plus the interest gained during the third year. That is equal to 10,612.08. Okay? So for the fourth year, the interest gained would be 10,612.08 times 0.02 times 1. Okay? We use here as principal the value of the investment at the end of third year. 10,612.08 times 0.02 times 1, no, for one whole year, the fourth year, that is equal to 212.24. Okay? The value of the investment at the end of fourth year would be 10,612.08, the value of the investment at the end of third year, plus the gained interest for the fourth year, which is 212.24. That makes it 10,824.32. Okay? So to answer how much would he have at the end of 4 years if the interest is compounded, our answer would be 10,824.32. Okay? In compound interest, we know that the interest is computed every end of each interest period. So we can observe that the amount at the end of each period would be like this one. At the end of first year, the value of the investment would be principal plus the interest gained, P times I times N. Okay, we have here 1 for N, meaning at the end of 1 year, okay, the future value would be P times quantity 1 plus I times 1, or simply P times quantity 1 plus I. Okay? The value of the investment for the second year would be F sub 2 would be equal to P times quantity 1 plus I. Notice that this is the value of the investment from the previous year. Okay, the value of the investment at the end of first year. That will be now our new principal times quantity 1 plus I times 1. This is for the interest gained for another one whole year, the second year. That's another one whole year. 1 plus I times 1 plus I. That gives us 1 plus I squared. The value of the investment at the end of second year, F sub 2, would be P times quantity 1 plus I squared. At the end of third year, the value of the investment would be F sub 3 is equal to P times quantity 1 plus I squared. This is the value of the investment at the end of the previous year. The value of the investment at the end of second year times 1 plus I times 1. This is for the interest gained for another one whole year, the third year. Another one whole year. That's 1 plus I squared times 1 plus I. That gives us 1 plus I cubed. The value of the investment at the end of third year, F sub 3, would be P times quantity 1 plus I cubed. Okay? And the value of the investment at the end of fourth year would be P times quantity 1 plus I cubed. We have here again the value of the investment from the previous year, the value of the investment at the end of third year, times 1 plus I times 1. This is for the interest gained for another one whole year, the fourth year. That's another one whole year. 1 plus I cubed times 1 plus I. That gives us 1 plus I raised to 4. So the value of the investment at the end of fourth year would be P times quantity 1 plus I raised to 4. Okay? Notice that at the end of first year, we have here an exponent 1. At the end of second year, we have here an exponent 2. At the end of third year, we have here an exponent 3. And at the end of fourth year, we have here an exponent 4. Observing the pattern, we can say that the future value of an investment, okay, invested in compound interest would be P times quantity 1 plus I raised to N. Okay, we can apply this formula in our previous example. So going back to example number 2, Jose invested 10,000 pesos in a cooperative group that offers 2% interest compounded annually. How much would he have at the end of 4 years? We can use the formula future worth is equal to the principal times quantity 1 plus I raised to N. Substituting 10,000 for the principal, 2% or 0.02 for the interest rate per period, and 4 for number of periods, okay, that's 4 years, we will still get the same answer, 10,824.32. Okay? Based on the examples that we had, we can clearly see the difference between simple and compound interest. For example number 1, an investment of 10,000 pesos for 4 years at 2% simple interest rate will give a future value of 10,800 pesos. For example number 2, the same amount of investment, 10,000 pesos, for the same amount of time, 4 years, but at 2% compounded annual interest, will give a future value of 10,824.32, which is greater than the one we had for simple interest. Okay? And that's it for now. So what have we learned for today? We were able to define basic terminologies in business mathematics. We were able to explain simple interest, and we were also able to explain compound interest. In our next video, we will have simple and compound interest part 2. We'll be having more sample problems so that we can distinguish simple and compound interest from one another much better. For more related practice problems, you may use our QuexBook General Mathematics app available from Google Play Store and answer Chapter 4. Thank you and God bless!